What do you see in this picture? You see people, buildings, a street, and signs. It seems simple to humans to recognize what objects are just by looking at them. However, computer vision isn't quite so simple. When our eyes look at an object, they can't say what they are looking at. Only our brains can interpret that information. In the same way, a photo taken by a camera is just a collection of pixels. It holds no information about the objects in the photo itself. The computer has to process the image to get information about the objects inside it. Computer vision has a wide range of applications, including medicine, autonomous vehicles, industry, and even law enforcement. Each uses a process uniquely optimized to its needs. Despite this, most computer vision processes can be distilled into a few basic steps. First, the image needs to be collected using a sensor or camera. Next, the image needs to be enhanced to remove any noise and also to improve the contrast. Secondly, the image is broken down into features such as lines, edges, or points. Thirdly, the computer uses these identified features to recognize objects in the image based on its programming. Lastly, the computer makes a decision based on what it has seen. This could be deciding whether a product has passed an inspection or whether a medical sample is positive for a particular condition. Here at UCL, research is being carried out in many areas of computer vision, such as cell phenotype recognition, facial recognition, 3D object recognition, and disease progression modeling. But for this video, let's just focus on one: detection of malarial parasites. Malaria is a mosquito-borne disease that attacks the liver and blood of an infected individual. It is treatable if detected and treated early. Yet in 2015, malaria infected 214 million people and killed 438,000. One part of the problem is that in order to track the severity of the infection or to see how well a patient is responding to treatment, a blood sample needs to be collected, and the density of malarial parasites in the blood needs to be counted under a microscope by a trained professional. This is not only time-consuming but also labor-intensive. A team here at UCL is working on using computer vision to automate this process. This could potentially increase the rate at which results are obtained and also reduce the need for expert labor. Additionally, faster results could help doctors to identify earlier if more intense treatment is required, which could increase the chances of survival for the patient. It could also lead to the faster discharge of cured patients, freeing up hospital resources. This is just one of the ways computer vision can be used to help and even save lives. Also, with new technologies and techniques constantly being developed, it has a huge potential to make a positive change in the world. There are much more research areas within this field which are just as exciting, and I encourage you to find out more.